And welcome back everybody, and today on this episode I've got power supply, and let me turn it around a little bit better. There you go. As you can see, there's some water damage on there. That's not a problem. Well, hopefully it's not a problem, but to identify this thing, as soon as I saw it, I saw FIT, Physics Department, and FIT is the Footscray Institute of Technology. I don't think it exists anymore. I think it's now Victoria University, but back in the day there was a Footscray Tech College where boys went to do their high school years, and also they had classes for apprentices, electricians, plumbers, carpenters, whatever. And clearly the technology department itself had a physics department, and I suspect that this was not only made there but designed in-house as well. So what we've got an overload protected power supply, and as you can see, the gauge has probably seen better days. Probably doesn't work at all. And we've got our cut-out currents, 3 amp, 1 amp, 3 amp and 6 amp. Okay. AC or DC output, on switch, off switch, and output light and mains light. Cool, cool. Oh, by the way, I did a bit of research on it, and Footscray Institute came into existence in 1968. So the oldest, I'm assuming, the oldest this thing can be is about, what is it, 54 years old. So anyway, that's nice to know, and yeah, I reckon they had a woodworking department in there too, sure. So let's have a look at the back. And it's heavy. There's one big transformer. So certainly, I don't know what the output voltage on that would be. I think I'll work it out later. So what have we got? Variac, nice, and I reckon I'm guessing, but rectifiers, cool. And we've got this thing here. Hope it's an octal socket. Yeah, it is, and it's a relay. Jeez. Hope that works. Something Melbourne 10R. And that's all it says on it. So, anyway, let's put that in. Where's my notch? Gotcha. And what else we got? A Sprague, electro. Looks like another electro there. Couple of resistors, blah blah blah. What else we got? What's that? ANR type 2155. It's got voltages on it. 9.5, 8.5, 7.5, 6.3. And maximum secondary current 240 at 50 hertz. 12.6 and 15 volt. Okay, okay. Fair enough, fair enough. So, the other thing, this did come with some documentation, and a bunch of papers were stuffed inside. I've just had a brief look through them. So, from what I can gather, just, again, a cursory glance at this, there were some issues with it, and the gentleman, I'm assuming the gentleman, has worked on it and got it going again. Well, I'm hoping anyway. Anyway, so whatever parts that is, anyway, that doesn't tell me much. Just make diagrams so it doesn't lose track of things. That's good. And some more stuff. Oh yeah, fuse. I saw some fuses there. Should test those, make sure they're okay. Okay, goes to the high voltage input there. Okay, cool. Some more diagrams. What's that? Oh yeah, Variac. Yep, cool. What else we got? In 1990, what's he say? A fault has developed where pin 5 of the octal relay, okay, it's a relay of course, meets its mating socket on the chassis. What looks like rejiggling the relay fixes the problem. Okay. So pin 5 meets its mating socket on the chassis, wriggling the relay. Okay, cool. Keep that in mind. What's it got here? Problem, no DC output. Reason pin 5 on octal not making contact with pin on plug in relay. Cleaning socket per or something fixed the problem. Also something metal contact, scratching metal contact help. Note, with power off, note at rest contacts 4 and 1 are made, 5 and 8 are made. On the 5th of the 10th, 93, faulty pins 5 and 7 cleaned and working okay. Well, that's good. That was a little bit there. Good boy. Okay, got just about an essay here. In 1991, 12th of April, problems with the FIT power supply. Model 10, okay. But front meter reads the DC voltage okay. You just added that in. Symptoms, no DC, something at battery terminals. Okay. Checks, no armature clatter when on button pushed. In fact, a heavy current is drawn somewhere between the main top lamp dims, somewhere, okay, and the main top lamp dims. To fix and isolate, removing relay and pressing on button still shows heavy current drawn somewhere and about 0.5 volt across pins 3 and 6 of relay socket. Removing overload, something or other, overload CIT board clears the heavy current problem, which appears to be the BT Y79 permanently tripped. Okay, a little diagram of what looks like a plug. Okay. Removing the lead to the longest leg of the BT79 cleared the problem. But the fault was something or other read relay which remained closed after an overload. Okay, so that might still be happening, don't know. Expected voltage when working correctly on BT79, and what is it? 8 volts? 8 volts. I'm guessing, yeah. I'm checking the read relay contacts. They were locked closed when they should have been open. The read relay is normally open till an overload occurs. To check the something action of the relay and BT79 when the unit is locked on via the octal relay, something short the read relay out and the octal relay will drop, and also something to be continued. And our last bit of paper, and again, the 1st of January 1989. Problems, no DC, AC operation. Okay. The wire from the terminal X did not appear to be continuous. Some probing around this area fixed it up. Well, that's it, just probe around and hopefully you fix it up. We all know that works, and it does. I'm not being sarcastic, but it does. You just, probe around, all good with working with it. Okay, so we had some problems. He appears to have fixed it, and I'm hoping it works. I'm going to turn this thing around. Heavy as all buggery too. That transformer. Gee. All right. let's keep the tape running, hey? And let's see if this thing works. And I'll show you what I'm doing. So, given that that gauge doesn't work, we'll just use the old multimeter. And I've just got my alligator clips. And I will connect these to the multimeter. And we can read some DC, hopefully. We'll be able to read DC voltage. Let's just put them on the floor there. Okay. I think you can see it. I think that's better, yeah. So the cutout current, I'll leave it on 3 amp. That's off. There's no, I'm wondering if that's an on-off switch completely. On and off switch. And there's our mains light there. Okay, let's put a bit of power into it. And I'll be watching my current limiter as well. So I'm going to bring it up to 90 volts with mains power. Let's hit the on switch. Still nothing. Okay, do I need to give it more power? Or is the switch faulty? I'm at 180 volts. Let's... Oh yeah! Oh yeah! We've got voltage. 9 volts of DC. 8. So I've just turned it off to see if it goes down to 8. Taken a while. But if I bring it up a little bit, what will it read me? 2.9, 2.8. Four volts. That's not too bad. 13.13, 0.14, that's all right. No, I know I haven't got it up at close to 240 volts of input, but what's it go up to? 26 volts. And you know what, we might as well, everything's looking good, there's no smoke. I'm going to bring it up to full power. Okay, and we've jumped up to 33.7 volts. Cool. Let's off switch works. Cool. Okay. Let's see if AC works. I'll give it a bit of power. That doesn't seem to do... Oh, well, actually, turn it on first, hey? Oh, it works. 5 volts of AC. I suppose the physics department would probably have a need to run AC voltage as well, and that goes up to 25 volts of AC, which is probably, at a guess, the what the power transformer outputs, 25 volts. I would guess. No need to rectify it or anything like that. Cool. It's very cool. It bloody works. I am amazed. I really didn't think it would. And gee, where do you get a schematic for one of these? Well, I reckon the answer is you don't. I mean, you know, again, I'm convinced that this was designed and made within the tech school. So look, what I'm going to do is, pardon me, there we go. We'll have a look at that electro, and certainly that's got to go. And clearly, I'm assuming all the fuses are working. That issue that he had, though, that he said he had with the once the overload trips, the relay doesn't release itself, and that could still be an issue. But at least he gave an explanation as to how to fix it, and I'm going to have to try and source another one of these gauges. I think it'd be nice to have it work, but I've got some things to do, and I will come back later and check out what's that. It's a Sprague. It's just some wires holding it in. Fair enough. I would have put it somewhere else myself, but never mind. And hopefully, whatever value that is, I've got one, and that grey looks to be electro. I should have one of them. I'm hoping. But anyway, come back later and keep working on this. I'm very pleased that it actually works, because, yeah, I think this is the sort of thing that I'm punching above my weight. Since I don't really, well, I've got a rough idea how it works, but, you know, shit. It's not a radio. That's it. Okay, back soon. Okay, so here's that Sprague electro, and it's 500 microfarad at 75 volts. Now, do I have a 500 microfarad at 75 volts? No. But luckily, I have this. I have a 470 microfarad at 400 volts, and that will do. Now, I was looking at the wiring. You can see it here. So positive here, negative there, black and red wire, positive, negative, sounds good. And it appears that the black wire, of course, goes to the negative, and it's connected to the positive. Now, that's weird, and that shouldn't happen. And I was actually trying to buzz it out, and they should be connected, but they're not. That's okay. And what I did find, and I don't want to make this too suspenseful, but whoever fixed this up, they've just done this. And so there's our negative, and there's a little bit of wire there. Why you've got that there is beyond me. Oh man, things some people do. I mean, you can't just take things at face value sometimes, especially when you've got positive and negative on an electrode connected together. That's not going to work, not to my knowledge anyway. So get rid of that. Bloody hell. Alright, I'm going to work out where I'm going to mount this, and probably just mount it there, I guess. Pretty much out of the way. I'll mount it like that. Anyway, I'll work something out, and I'll connect that all up, and it should work okay. And there's couple of, as I said, just see it there, I'll zoom in. Right there you can see it quite well. Looks like an electro, may not be. It's got the little indent on one end and what appears to be a poly just behind it there. So looks like it's fits in a slot, and it's certainly jiggling left and right. So anyway, I'll deal with that later, and I'll get that electro in, and we'll see how we go. Okay, now before I change that electro, I found something amongst all those papers that were in the back of the unit, and I just threw them on the bench next to me, and one of them actually sort of hit itself. I just noticed it now, and I've got myself the schematic. Very, very cool. Bring that light down. So, 1971. So we've got a date, okay, for it. And a Mr. Kluman, W. Kluman. Good on him. Good on him. He designed this. And just looking at that, and the power supply is, where is it? Up here. So 240 volts in, 24 volts out. As I thought, given that test I ran yesterday on the AC output, it was what, 25 volts? And the other transformer, 240 volts in and 9.5, well there is, 9.5 volts out. Now, look at that. There's our electro. And that says 250 microfarad at 50 volts. Cool. Well, let me see. I'm going to go check to see. Well, I'm not going to use that 470 one. I mean, the guy who put that in, I guess this is all he had. He had a 500 microfarad, but doubling the capacitance. I wonder if that is why, instead of, say, 24 volts of DC output, I had 55. I don't know. We'll find out, though. I'm going to see if I've got any 250s, or if I can make 250 up. So just give me a second. And I'm back, and lo and behold, I've got myself 250 microfarad at 50 volts. I knew these would come in handy. I've had them for, I don't know, about a year. Bought a packet of them, and or about 5 of them. So super duper. I am going to put that in, and then we'll run a test on it and see what happens. Okay, so I've got that cap in, and I decided I wasn't going to put it there, and I thought, no, I'm going to glue it to the chassis, because obviously the faceplate there, or the chassis itself, whole thing comes out, takes everything with it, so hey, make it easier for me or somebody else in the future, and if they ever take it out. Alright, so I've hooked the multimeter up. Let's switch it on to DC, and let's get this thing some power. And up we go. Now we'll take it up. 130 volts. Let's actually, ouch, hit my head. Turn the switch on, power on. Let's go for a bit more. 180 volts. And we've got power. Let me turn it off. Back on again. And I'll turn, where's the variac? There we go. So I'll give it full power on the variac. Oh well, yeah, 240 volts. And let's just turn the unit up and see what sort of voltage we get. 33 volts. Okay, DC, cool. And nothing smoking, cool. While we're at this, let's run a test. Let's just check some voltage, and curious to see how much voltage is going through the electrolytic. 33 volts, cool. And if we go to AC, again I'm just curious to see the output voltage. So is it 25? That's just 239 volts. Oh, is that the input? Okay, that's simple. I thought that was the output. Sorry, yeah, I thought that was the output secondary voltage. It's not. So secondary voltage is around there somewhere, and yeah, you can't see it. Okay, cool, all cool. All right, I am going to switch it off. Cool, it's off, and we'll start looking at that little thing there, and I'll just clear this workspace up, and we'll see what's on that board. Well, I've got the little board out, and this is what's on it. So, diode, resistor, a couple of resistors. Take that to be another diode. Yep. But anyway, it's an electrolytic, and it's 50 volt at 250 microfarad, and which is there. And this is the one I mistook, that 500 UF. I mistook that for that. I simply saw a transformer there, but that's a secondary transformer that's pumping out 9.5 volts. So, why was there? I've looked at the whole thing and cannot see a 500 UF capacitor. However, it is connected up. According to the schematic, we've got the where are we? Where's that? Where the hell am I? Okay. Switch between AC and DC is right there, and that's that little switch there. And we have two wires coming off it going to that, what was 500 UF. Think you can see it. I'm sure you can. There it is, see, the little blue thing. And he's marked it as silicon power diodes. Now, I don't see any, to be honest, but somebody has drawn a capacitor symbol in there. So there's no other mention in it. This could be I don't know if the technology department did, the physics department did that, or whoever. But I'm going to put that 470 in its back in its place there, and I'll change this and I'll take that away and whack it in there where it should be. So, for want of there was no mention in the guy's notes at all as to that 500 UF. Given that it does work, it was working, it works now. But I think I'll sort of play it safe. It's more a gut feeling than anything. And I'm rambling on here, but I'm going to put that 470 in its place. Okay, so there's that 470 UF in place of a 500, and it's all glued in. And there it is there, that 250 is on the board, and the board is back in its slot. So let's test it out. And of course I'm still trying to nut out why there's this big honking capacitor there, and clearly it's been installed by, I'm assuming, the fellow who owned this thing after it left Footscray Institute of Technology, whatever way it left there, and he's put it in there because, remember, it was the original cap was just wired in there with some electrical wire, as you recall. But anyway, I have no idea why he would have put that in there. I just don't have the expertise to work these sort of things out. But it does work anyway, so hopefully with those two caps in there, it's going to work fine. So let's switch it on and give it, knowing that this thing needs to be up to at least 170 or 80 volts to switch on. And I'll just bring the multimeter up. And we've got power. And 13 volts so far. Cool. No smoke, no nothing. All good. Right, let's bring it up to Variac up to full power. Not that much. That'll do. All looking good. And what's our maximum? Again, 33.7 volts. Fair enough, fair enough. That's good. Well, that's done. I'm going to check those resistors there, and pretty much that's it. I think there's not really much in this. I'm just looking at the fluctuation of the voltage, and it's pretty good. 1 volt either way, oh well, and 2. Certainly much more stable than I think our mains power anyway. That's alright, that's good. Anyway, I'll check those resistors. I don't really think, again, I don't think there's much more that can be done with this. So I'll be back shortly. Okay, so I checked out the resistors and look, they're all fine. What I have done in the interim was I decided to put in a mains power switch, and so I've just tapped into the main feed there off the power cord and just routed it through that switch which I've installed down there, and drilling and whatnot, but so makes me feel a lot better. The other thing I did notice on the schematic, it actually explains these the values here on the current cutout. In fact, that's 300 milliamps, 1 amp, 3 amp, 6 amp. Because the way it looks, 3 amp, 1 amp, 3 amp, 6 amp. Strange. Anyway, so we know it's 300 milliamp. Let's do a final test and we'll wrap this up. So let's just get this. Where are my cables? Where are my cables? Here we go. That will test the switch too. It should work. I'm just connecting up multimeter, and it's down there. You can see it all. Alright, so it's off, and let's give it some power. I'm giving it full power. Still on Variac, of course. I just like to do that. So mains light came on. I think you saw it, and we'll turn that down to 0, and let's hit on. Oh yeah, 9. Even at 0, it was registering whatever, 15 volts, 20 volts, something. So that'll go down to whatever it wants to go down to. So it's working well. And again, 34 volts maximum. Switch that off. You're off. Okay. Now, get that out. I have like your advice, please. Well, you guys that know a hell of a lot more than me. To be honest, I mean, it's a nice little unit, but it's only 34 volts output, and I need something that's going to put out at least 100 volts if I'm going to work on a battery operated radio. They need 90 volts of DC for the plate and 1.5 for the filament. So can I, and I'm thinking, because I really don't know, power transformer only puts out 25 volts of AC. So if I change that so that the output is, say, 120 volts, 150 volts AC, is that going to work? Or does it require, if I do that, change that to a higher output transformer, do we need to make changes in the circuitry? For example, do we need to increase the voltage value for that 250 microfarad cap, which is currently only at 50 volts? The resistors need to be changed and updated, and can the rectifier handle that? I would assume the rectifiers could. I would assume those diodes here, the power diodes, they should be 1000 volts. Anyway, that's my question, guys, and I really would appreciate your thoughts on this. What I will do, I'll put up the schematic that I've got for this, as much of a schematic as it is, give you a better idea as well. So anyway, I'm looking forward to your replies and your comments. So thank you so much for watching. Again, I'm pleased this works. It's a good little unit to have, and doesn't take up much room, which is really good, so I could leave it on the bench. Anyway, I'll be back soon. Well, I don't know what with, but probably a radio. Anyway, take care, everybody. Have fun. Stay safe.